Okay, we have a MacBook Air. The description it's random on and off, yeah. So they say the machine sometimes comes on and other times it doesn't. So this has been assessed. It's coming from a repair shop. And okay, I suppose these are the screws. And yeah, let's see why it sometimes comes on and other times it doesn't come on. So right now we are going to see if it comes on, and even if it does, we are not going to rely on that. It's happening to the screen. So even if it does come on, we're not going to rely on that because they say it's randomly goes on and off. Let's see what's happening to our screen. Okay, so this is an A1466. It's a 2015, 2017 because of the JTEC. I always mention that if the JTEC it's a bigger, that's a 2013, 2014 and below. But if it's smaller, then that is a 2015 and 2017. So let's just hit the power button and see if the device turns on. Okay, we're not sure. Maybe we don't have a charged battery. Let's disconnect the battery and plug charger to it. It's the Maxif 2. Maxif 2. Okay, let's see. Okay, so um, from 2011, the Mac design is such that when you connect power to it, especially the MacBook Air, 2011, 2012, 2013, up to 2017, when you connect power to it, the fan should start by itself. But in this case, we don't have fan spin, so which means this is a no power. So what we want to obviously, it's actually good that we get in to say that it's not turning on because they say sometimes it does turn on and other times it doesn't. Because if it was turning on now, we obviously want to wait to see that it's not turning on before we go ahead and fix it, or we just have to go ahead and take the board out and see why it would sometimes not turn on. So let's see what we have on our PP bus, and then also, we want to see if the device is partially making its way into SO state. So let's open up the board view. This is an 80-00165. 80-00165. So on the other side, we want to see what we have on our PP bus. 8.6 will mean that we have a proper communication between our ISL and SMC. 8.23 will mean that we do not have that. 8.6, that's good. We have proper communication between the ISL and the SMC. Now, let's see if the device is partially making its way into SO state. We can check that. We can check for voltage on L7520. Let's see, do we have anything here on this inductor here? Do we have anything? Okay, that's fine. So that means that we might have something on the board, like a corrosion or some sort, or something. So let's quickly, and then something else also. The board warms up, even though so it means that the device is trying to start, but it's not doing so. The board is actually warm, and our 5-volt line, which is our SO line, that rail would usually be active, which you would usually get voltage on that line in the case of when the device is in SO state. But in this case, the device is we getting 1 volt on a 5-volt line, which means that the device is trying to start. So let's quickly take the board out and see what's happening on the other side of the board, as we hope that is where our problem is going to be. So most of the regular checks that we would want to do are going to fall away because of the state of the board. So right now we know that okay, the device, most of the rails, the primary rails will be present, and then we just want to see why the device is not, it's not fully transitioning into SO. Okay, put this out. Let's put the shell on the side. Okay, so this is 2017. It's a 1.8. Yeah, let's see. Is there any section of the board that is partially corroded? Anything? Okay, it actually looks like this was liquid damage because I see a bit of a, see that? That's from liquid. That's from liquid. So let's do our scan. Let's start from the right to the left. Let's see, and we also have a bit of this looks like there was also liquid in this region, so we may have to reflow the SMC as well. But before that, let's continue scanning. Let's continue scanning. That, let's see, is that shorted in any way? Let's see if that is shorted in any way. Okay, that's no. Hmm. Okay, we don't, there's nothing really major here. Also here, this, you see this was wiped, so it looks like they also wiped this off. Hmm. Okay, so, and okay, we also have, aha, okay, so this is here, so that's gonna be our power here. So we have missing components here. So we're going to address that, and maybe also address the SMC. So I'm just going to get a donor board to give you guys an idea. So the components that I'm missing, so these are the components missing. So you have one, two, how many components missing? So one, two, okay, just two. So just two are missing. And that is the 3 volt and the 5 volt line. Okay, so this is flip to the other side. What we have missing is R50 77 75 36 as well as C7537. So those are definitely important to the overall function of U7501. Let's open up our schematic 00165 00165. So let's go to U7501, U7501. So that is our 5 volt, 3 volt power supply. So this, the components that I'm missing are definitely going to play a critical role in the overall function of U7501. So let's place those components back, and then we gradually work our way from there. Okay, so we know, let's flip our board, orient the board the same way our board is. So let's do that. So what we have missing is, so we know 1, 2, 3 are present on the board, which is, so 1, 2, 3 are present on the board. What is missing is 4, 5. That's an empty space. So 1, 2, 3 are present on the board, 4 and 5 are missing. This is an empty space. So let's just confirm that. Yeah. So 1, 2, 3. So, and also we, number 2 is also not looking good. So we're also going to replace that. So this and that needs to go. Now let's look at the track point, and also we should have a missing cap there. So that guy and then this guy. So we know that, so the pads, so first we had to review the pads. We do know, let's see, this and that. Okay, but so, okay, so if this pad is missing, we can actually use this pad that has no stuff. Do you understand what I'm saying? So because this is connected to that, and then this is connected to that. So if, since this is no stuff, but and this pad, if we find this pad to be missing, we can just use this space instead. Do you understand? So, but let's see. We did try to review the pad. So this is the no stuff. So yeah, I think we're good. I think we're good. But we also gonna, so actually, what will be good is, let's just remove this too, because they do not look okay to me. That will also give us better room to use our soldering iron. Okay, let's place the components one after the order. So let's go like this instead of going like this. So let's start from top guy here. Start from the capacitor. This one here. We Okay, yeah, that's it. So we actually gonna use that cap on the no stuff. Do you understand? And then followed by the resistor. We still gonna flow those in place. So just wanna place them first. Okay, now let's flow them in place. Okay, let's also give a bit of a reflow to the SMC. We are removing the edge bands. Which one is that? No, you didn't do anything wrong. But that was not a 16 inches, eh? In 1990. So I'm just gonna. Okay, that's fine. So while this is cool enough, so now whenever you're doing any type of liquid damage repair, so usually what happens is there are two problems you might run into. You get a case of the component itself being faulty, and then what also happens is you get liquid heats then eats into the pad of the component. Now usually what happens is sometimes you get a broken line. So what would then happen is, so sometimes you can actually replace the components that you see that are not looking good, which is, for example, this and this, for example, are not looking good. You replace this, but what you don't know is that the pad between them to the main chip itself is broken, or to the next component is broken. So if after you've replaced that, you need to ensure that you have proper communication to the destination of the track, the track point, which is obviously represented by TPs. Like you see the test pads. You want to you want to make sure that there is still continuity between them. So usually the mistake would be that I will replace XYZ component, but then I do not check to see that I have continuity between the beginning of my component and the supposed destination of my component. Do you understand? So this is usually a case where you have a liquid damage, because liquid damage obviously of sometimes it does not only affect the component itself, it also affects the pads between the components. Do you understand? So in this case now, so usually what I would do is, so for example, what we've just done here now, we decided to use the no stuff pad, which is what it should be that should be the note. So we know that 1, 2, 3 looks fine, but then we have to remove this two. Now this and this and this were not present on the board, and then this here is unpopulated. This is not used. So, but then because we have a missing part, what we could also do is we could kind of move the capacitor in a way that this becomes its starting point, and then this becomes its end point. So we just put a bigger solder ball here, and then we just add the cap, and then this will sit here. Alternatively, what we decided to do, so that is how I would do it. So I would sometimes decide to put a kind of like a bigger solder here that would join this and this. Do you understand? But then what we decided to do is to just move this to this point here. Why? Because pin 2 and pin 2 are the same thing, and the pin 1 of the pin 1 are the same thing. And then again, what we also need to ensure is that the communication between this, and this are still okay. So we just need to use a multimeter to confirm that. So which, yeah, the one in the middle. So the one in the middle, this, but that's going to be this guy here and this. and that's fine. Okay, that's fine. Okay, so now let's test our board to see what state our board is in. Because initially we knew that we were getting 1 volt on our SO line. So, and then as you guys also know, in cases like this, I don't want to have the fan connected because I don't want to kill myself expecting the fan spin. So so yeah, I want to actually let the multimeter do the multimeter doing the turning for you is less disappointing than you not seeing the fan spin. So yeah, let's let the multimeter do the work. Okay, so we know that our SMC was not a problem at first, but then again we had to just do a reflow anyway. Now, okay, PPDC in. Let's confirm that we are PPDC in here. 16.6, that's fine. PP3P42, we can confirm here. 3.4, that's fine. PP bus, let's confirm from here. 8.6, that is fine. Here we had 0.1 volt. Oh, 1 volt. Okay, yeah, let's see what we have now. So 5 volt will mean that we are now it's doing its work. But if it's, yeah, 1 volt still, then we have to go back. Now it's 0 volt actually. Okay, so we are not even, it's not even working now. So that's fine. Now let's go to where we worked on to find out. Okay, so, but wait. So what we did, we had to use, we left this unpopulated and then we used this instead. But this and this are all on the same line, and this are all on the same line. So I did not. So it's pretty much okay for us to use this. So it's not wrong for us to use that because this. So if this chip was here, it's still the same as though the chip was here. And if the chip is here, it's still as though this chip is here. But what we now want to confirm is, do we have continuity between this and that? Because we did check continuity here, but we didn't check continuity between this and that. So let's see, do we have continuity there? Let's check for continuity. So I want to check for continuity between, so from here, we can use this point and then that point. Is it? Yeah. Yes, we have continuity, and then the other side. Wait, um, we're supposed to get continuity between that cap here and here, and that we don't have. So this and this, there is a broken line there. So this is supposed to beep with that. So I'm just going to show you guys what I'm trying to say on a different board. This here. So if we do this, so like this, so this is supposed to beep with this part here, which is where we decided to use that part, and this we're supposed to get a beep, but here the part that we use, and here we don't have any beep. So we need to put a soda, put, put a let's put something there to do that, to create. Actually, so what we can just do is let's move it closer then. Do you understand? So let's move it back. So remember, it was here. We decided to use this point here because we thought, since we still have parts here, but since the part is not connected, so we want to move the component. We want to move our capacitor back. What am I doing? Wait, wait. Um, this is supposed to be a resistor, not a capacitor. What am I doing? Okay, so there's supposed to be a resistor here, not a capacitor.
Oh, so you replace the
Yeah, but so but even though no, that's fine. That is fine. Even though we do install a capacitor here, it's the same thing because it would mean that we have a resistor and a capacitor on the same parallel lines. Do you understand? Because if we had a resistor here and a capacitor here, it would still mean that the capacitor and resistors are connected. So that's fine. But the problem we're having is we don't have continuity between pin 2 of 67537 and pin 2 there's no continuity between this. This is one. There's no continuity between this and this. So what I want to do is I'm going to put a solder here to allow me join this and this. But because this is firewall, remember we're using this, so I'm going to move this here, and then that closes the gap. Then I can just put a solder there. So let's do that. Okay, let's get a solder block. Let's put it there, and that should do the magic. There's still a small gap between them. So let's add this one here. Are you able to see the gap? Okay, that closes the gap. Okay. So now what we want to do is because we checked continuity between. Wait, am I losing my mind? Because we checked continuity between this and this. Was it present? Yes. But there was no continuity between this and this. Yeah. So yeah. So now we want to just see. Yeah. So that is where. Yeah. That's where we at. So the continuity was not. It wasn't broken from this point. So this point was fine. So it was just to. Yeah. So yeah. So let's see if we have something different now. PPDC in. Okay, that's fine. PP3P42. Wait, PP342 is okay. That's present. PP bus 8.5. That's fine. What do we have on our inductor? That's a beautiful 5 volt, and that's a beautiful working machine. Okay, now we can connect. Now we can connect our fan. Okay. So now we're not expecting to get any type of heart attack. So okay, so that is so. Let's get a screen to see that we are posting. That's a beautiful fan spin. It's one thing to have a fan spin. It's another thing to get a working board. So let's see. Are we posting? Okay, yes, we are posting. So this is test purposes only. So we're not expecting to get image, but the fact that we get this, that gives us yeah, all that we need. So the next thing we want to do now is, obviously this is not a type of repair where you're looking for image on the screen. That's why we use this. But yeah, we are going to use the client screen, and we're expecting to see a beautiful Apple logo. After which, this is going to be moved to Peter to take over. Let's see. We're only going to connect the cables we need for the test. We don't really need the trackpad cable and track keyboard and trackpad keyboard and trackpad cable, but it's okay. We're just gonna hold on the Alt key because we don't want the machine to boot. We just want to see that the device is working. We have image. Ah, waiting. Do we even have a fan spin? No, what's happening here? Uh, okay, we may have to scratch, do a little bit of scratching on the DC jack. Okay, let's try that again. Hmm, interesting. What's happening? That was weird. Okay, let's hold the Alt key. It's taking longer than usual. Okay, so let's try this again. If it does the same thing, then we have to take a different approach. Okay, find spins. Do we have anything on the screen? Okay, now we do. Okay, so I'm just going to try that again for the second time just to be sure that, let's see, we want to watch the behavior of the fan. If it starts and stops, then that's a concern. Let's see, does it start, does it stop? No, it doesn't. Okay, so, and then what do we have on the screen? Okay, that's fine, but let's just again for the last time, let's connect a charger, watch the behavior of the fan. Does it start and stop? Okay, yeah, that's pretty much okay. So let's see, and then what do we have on our screen? Okay, that's beautiful. That's a successfully completed repair. So the next thing we're going to do is to clean that region. Let's quickly do that, and then this can now go through the next phase where we get to assemble the device and then do the required test. And yeah, and then this can go to a happy client. Uh, okay. Just before we pass it over, let's just confirm that the board is still starting. You should check a screen that I can get image from for me also, right? We can use that instead. Testing screen. Get something that at least we can get image from our screen because instead of having to change while we're working. Okay, so as you guys can see, we still have a working machine. Thank you guys. I will see you guys in the next one.